cutting of the teeth is not an issue for an internal gear. And also you have to ensure that the root space width at the bottom of at the root of the gear is at least 0.2 times the normal module of the gear. Any queries? Anything? During meshing of internal gears, you come across 3 types of interferences. Now, here also there is no standardization on what each interference is called. Now, what I have called is involute interference, or some books call it primary interference. Primary interference is the term used in French literature. The DIN doesn't specify any name for this, or then the American literature or English literature doesn't have a specific things for this thing. They talk as a general interference. Then you have a trochoid interference, which is also called a secondary interference. Then the third one is a trimming interference, which is called radial assembly interference. What it means is, trimming interference means you cannot assemble some combination, you cannot assemble the gear by sliding it radially. You have to assemble it axially. Now if there is no constraint of axial sliding, then this is not a big issue. But for the type A and B, these are the issues need to be taken care by choosing the addendum modification coefficient of the pinion as well as the addendum modification coefficient of the wheel or the internal gear. I've talked about that issue G, what is called a trimming interference can be the root width also can be taken care by choosing a proper addendum modification coefficient. That is independent of the pinion addendum modification coefficient. It is solely dependent on the addendum modification coefficient of the wheel. And any value higher than the minimum value, you will always have a crest width or the root space width greater than 0.2 mm. It is dependent solely on number of teeth, the module, pressure angle and helix angle. Now this is what is called the primary. You have a pointer. Now this is the contact at the reference diameter. As the gear rotates, the contact also moves along the line which is the common line tangent to the two base circles. Now when it goes beyond this, you will find for proper meshing, this will be the curve which is exactly opposite to the curve that is there on the gear. So you cannot extend the contact beyond this point. So if you have a meshing which is going beyond this point, then you will have what is called the involute interference or primary interference. And this is the formula to decide whether you will have a primary interference or what. One is this, or the simpler one which is equivalent to this, Z1 divided by absolute value of the number of teeth on the gear, internal gear, should be greater than 1 minus tan of the transverse pressure angle and the tip diameter divided by the transverse operating pressure angle. Now we come to the trochoid or secondary interference. In this case, as the gear rotates, This is the initial condition. As the gear rotates, this contact comes from here to here. Now whatever is the rotation, if that rotation is of the internal gear will be the rotation of the pinion divided by the transmission ratio, or not the transmission ratio, the gear ratio. So if that ratio is less, that value is less, then this will be will be fouling with the internal gear, and then you will have the secondary interference or the trochoid interference. Now this condition can be also avoided by using these formulae. I will not repeat the formulae because these are complex formulae, but if you use these values, lambda 1 into this should be greater than lambda 2, and where lambda 1 is this and lambda 2 is this, and how do you calculate the operating pressure angle? The transfer pressure angle is by this formula, and pressure angle at the tip diameter is with this formula. I think this will be most likely to be published in the gear technology issue, one of the next issues. I don't know when, not the immediate one, but I am talking to these people where it may get published. So formally you will have it handy, or you can contact me, I can supply this formula. Now we are talking about the trimming interference. I have dealt with earlier. As I said, it is not a major issue because if you are able to assemble axially, then it's not a major issue. You feed it in this way and it can get axial, but you cannot assemble it many a time if it is radially infed. Now this interference can be avoided if the difference between the internal gear and the pinion is at least greater than 10. But you will have to work it out whether it is feasible or not feasible. For that also there are formulae given. And these are the formulae. I will not read it out because it will may be found boring, so I wouldn't go into the formulae. Now you have a certain design and you need to know whether that has any of these interferences. Now you can use this formula to find out that is there. Now I have launched at this exhibition the gear software, geometric calculation software, where these can be taken care, and you will get the display showing what should be the choice of your addendum modification coefficient. Some sample of that is shown here. This is a sample of one of the display output. It says that because it is dependent on the pinion addendum modification coefficient, it gives you that value what it should be. Then you should not exceed the sigma, that means the sum of the addendum modification coefficient should be less than this. It should not exceed this value. So that one point you have to take care. You can split it up however you like, but also splitting, what it says is, for avoiding in primary interference, it should be less than this. And for avoiding the secondary interference, it should be less than this. That means it should be at least less than 0.4673. And to avoid the root space width to be greater than 0.2, it should be greater than 0.553. So that is the range that you will have to work at. And then once you choose this value, you can choose your value of K1 so that it doesn't exceed this. So this is how you get the calculation of both K1 and K2. I have told you what it gives. Now here, if you look at it, in this example, this value was greater than this value. It may be the other way around also. Or sometimes this value is in between the two values. If that is the case, then you cannot have, one of the conditions will not be met. Either you will have a secondary interference or you will have a value toothpaste width less than 0.2. And this is what basically is my presentation. The session is open for discussion. Any?
It's very good. Your knowledge is excellent. There's no problem. My question is now, from your point of view, will you recommend helical angle for internal gas? For example, for planetary gas, spur or helical gas are better.
This software can give you for both, spur as well as helical. So it will work for both the things. The formula will work for both the spur as well as helical gears.
Yes, of course, I agree that geometrically it works. It is in a helical gas with, as you know, axial force. And axial force acts not central, acts on the working pitch, on the working diameter, despite the gas tilts, okay? And this makes deformation and makes deflection. And what is the contact between this external gas with the internal? After this deflection, I see.
This can happen, but you will have to take care. If it is not like a planetary gearbox where it is a floating arrangement for the planets, then it's a problem. But if it is not a floating one, you can take care by bearing mountings that this doesn't happen.
Yes, of course. Is it possible? But if you have a design where the pinion with the external gear is not middle, it's one side, unlike in a planetary carrier, you have planetary carrier twist. So the pinion is on one pin which twists. So you have, from definition, tilted position of the external gear to the internal gear. If you have a helical angle there, not spur gear, and the spur is not this. Despite is my question further, will you recommend helical angle to internal gear?
I mean, to avoid that, it is definitely better to have a spur gear. But helical gear, if you are able to take care of the tilting, most of the time you are not able to do, because to mesh properly, you normally keep the planets floating. The planet carrier and the gears are floating. So it's better to go for spur gears in that case.
Thank you very much.
Thank you.